Okay, this is going to be effectively the last topic that we talk about in this class. Congratulations. Now, what I wanted to talk about today is the last factor that is kind of general interest in relativity. Now, we've already talked about length dilation, time dilation, where just the fact that you're moving at a different speed is going to change your perception of those two values. What we're going to talk about today is, well, probably the most popular or the most commonly seen equation in the history of the world. Einstein's energy mass equivalency statement. Now, here's what this means. E is just simply energy. M is mass, and C, I don't care, is the speed of light. Alright, so what this means is that every object that has mass is going to therefore have a certain amount of energy due to that mass. And if all of that mass were to be converted into energy, the total amount of energy would be the mass times the speed of light squared. Now, just a quick reminder here, the speed of light is just under 300 million meters per second. So if you take and square the speed of light, 300 million squared is a 9 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. A 9 with 14 zeros after it. So, 1,000, million, billion, trillion, 900 trillion times the mass. So, you can get an absolutely enormous amount of energy out of a relatively small amount of mass. Okay? Now, this is where it actually came from. If you were to look at this equation here, it works for everything. Problem is, in most cases in everyday life, you're not going to see very much mass getting converted into very much energy. Because of this, the only place that you're actually going to realize this or recognize it is in nuclear reactions. In nuclear reactions, there is a small but still finite amount of mass that gets converted into energy. Right? In that case, the amount of energy that is created equals the mass times the speed of light squared. All right? Without this equation and without this overall realization, there's a few things that we never would have actually seen happen. First one would be nuclear power. Without our understanding of how that power is generated, how much can be generated, and how to safely harness it utilizing this equation, we never would have been able to do it. The other thing that this equation really put into motion is the original atomic bombs. The Manhattan Project, all that lovely stuff that happened, wow, over 60 years ago now. Practically 70. But anyway, these two are a direct impact from this equation right here. Now, the most common thing that I get out of students after talking about this is it seems like a stretch of the imagination. Not just the E equals mc squared, but also the time dilation and the length dilation as well. Alright, the thing is, this one has been proven. We have proven this using nuclear power plants, We have proven this one using atomic bombs. Time dilation, proven using GPS satellites and other precise timing. This has been proven. This one less directly than the other ones, but realistically, if the time changes, then the length has to change also, or else you would run the risk of breaking the speed of light. Alright, so, as crazy as this stuff seems, it is all true, it is all proven, and no matter what you want to say or do, you got to deal with it. Now, some other really neat things that are happening in physics right now. And if you guys decide to go these routes, there may be some decent exploration, some decent things yet to come on it. Alright? Quantum relativity. Alright? This is the overall conundrum with this situation right here. Quantum has to do with small. Relativity has to do with large. This works with everything small, this works with everything large. This works with nothing small, this works with nothing large. What they're trying to do is find some type of a go-between that'll take relativity to quantum and quantum to relativity so we can understand the entire topic of what's going on. Alright? Other stuff that's going on now. String theory. This one is a really interesting topic. They feel that every single piece of matter, energy, photons, everything in the universe is simply a vibration on a string. The length of the string and the vibration of the string is going to determine exactly what's happening. Now, the problem with string theory, well, there's several problems with string theory. The first one is the math behind it is absolutely astronomical. A friend of mine in college, he was actually one of my professors, said that he wanted to go into string theory, but he was refused because he did not already have his doctorate in mathematics. The other thing that would be very difficult with string theory is actually proving any of it. You can make the math look as eloquent as you want, but the fact of the matter is you need to actually be able to tie it to the real world. This may never be able to be tied to the real world, but the scary thing is it still might be a decent possibility. Alright? And also superstring theory would go with that as well. Okay? And the last thing that is plaguing physicists right now is what's called GUT. GUT stands for Grand Unified Theory. The Grand Unified Theory is trying to unify together all forces under one heading. Alright? Because we've got different types of forces out there. There's electromagnetic forces, there's gravitational forces, there is nuclear forces, both strong and weak. Now, since every single one of these, deals with their own separate and distinct type of forces, physicists now are trying to find some way, to tie electromagnetic forces, gravity, strong and weak nuclear forces under one heading. It's absolutely driving people bonkers, but it is going to be one of the really, really cool things that's probably going to come out of the next, I'd say, decade to two of research. This is all of the theoretical physics that you are going to see in the near future. The applied physics you're going to see all around you. The stuff that engineers are coming up with nowadays is absolutely, bar none, some of the most impressive stuff that has ever arrived on the planet. And going from the iPhone to flat screen televisions to even your Xbox 360, your PlayStation 3. What is coming out with those is absolutely amazing. The graphics, the detail, the high definition, it is absolutely unsurpassed by anything of its time. And it is all going to be going further and further in the future as some of these things, these higher end physics, actually come into play. What you may see that's kind of a combination of theory and practice is what's called quantum computing. In which a computer is already doing the processes that you are going to ask it next week. So therefore there would be absolutely no lag time. They are doing things that is absolutely astronomical. Before you guys die, you may see people with computers implanted into their brains to basically act like their cell phone, act like their regular old computer. It is absolutely unbelievable what is possible in the future. There's going to be one more homework assignment. That homework assignment is going to be given to you tomorrow. After that homework assignment is done, I'm going to use you guys a little bit as manual labor to try to get my lab cleaned up a little bit, and you guys are free to go. It's been a pleasure working with you, and best of luck in the future. If you guys ever need anything from me, if you get stuck on a problem in college, you have my email address, and also just remember my YouTube channel. You can use any of those videos that you need that they might fit in, whatever. You are welcome to them. Best of luck in your future, and have a great life. Good luck with graduation.